Let us solve this question taken from electrochemistry. We have two electrode systems given with their electrode potential values. One is ferrous to Fe, another one is a redox electrode, ferric to ferrous electrode. The two values given are E0 for the ferrous to Fe electrode, that is metal ion metal electrode, is minus 0.44 volts, and the other one, redox electrode, ferric to ferrous electrode, is 0.77 volts. Using these two values, we have to find out E0 for another electrode system, that is ferric to metallic Fe electrode, that is Fe3 plus 3 electrons gives Fe. We need to find out E0 Fe3 plus oblique Fe from the data. Now the four options given are, the first option is 0.33 volts, second option is 1.21 volts, third option is minus 0.33 volts, and the fourth option is minus 0.04 volts. Let's try to find out which is the correct option. Here I would like to tell you that the required equation, ferric plus 3 electrons gives Fe, can be obtained from the first two equations which are given in the data. You need to simply add those two equations. If you add first and second equation, you get the third equation. But the problem is you cannot add E0 values simply because E0, electrode potential, is an intensive property, it is not an extensive property. So whenever equations are added, you can add up the extensive properties pertaining to that equation, but you cannot add intensive properties. So what we need to do is transform E0 into another property which is extensive. So what we do is we transform it into delta G0, free energy change. And we can add the delta G0s for the two equations, and then we get the delta G0 for the third equation. From that, again we get back E0. Look at the way it is done. Look at the solution. Now electrode potentials are not additives. It is necessary to consider the actual change in the free energy according to the relationship delta G0 equals to minus NF E0. This is the equation relating delta G0 with E0. Delta G0 equals to minus NF E0. Let me tell you, N stands for the number of electrons involved in the electrode reaction. F is Faraday, it is 96,500 coulombs, and E0 stands for standard reduction potential. Now look at the data. Fe2 plus 2 electrons gives Fe, E0 is minus 0.44 volts, corresponding delta G0 comes to 0.88 F. You can see delta G0 equals to minus 2 F into minus 0.44 volts. 2 because the number of electrons involved in the reaction is 2. 2 electrons are involved, so N comes to 2. So when you take N as 2 and put the value of E0, you get the value of delta G0 as 0.88 F. Now for the next equation, that is Fe3 plus electron gives Fe2 plus, E0 is 0.77 volts and corresponding delta G0 comes to minus 0.77 F. Now what you need to do is add these two delta G0 values. If you add them, you get the value. See, the one value is positive, the other one is negative. So if you add these two values, you get minus 0.11 F. Look at this. Adding total delta G0 for the reaction Fe3 plus 3 electrons gives Fe is 0.11 F. So using this, we can find out E0. So E0 Fe3 plus Fe is delta G0 divided by minus NF. So putting the values, you get the value minus 0.04 volts. This is the E0 corresponding to the equation ferric Fe3 plus 3 electrons gives Fe. That is how it is done. So first change the intensive property into extensive property and again get back the intensive property. So the correct answer, if you go back to the question, look at the correct option. The correct option is fourth option, minus 0.04 volts. That's all. Thank you.